In this video, I'm going to give you a quick explanation of how to combine like terms and use the distributive property. So in order for things to be considered like terms, they have to have the same variable or variables. It could have multiple, and they have to have the same exponent on those variables. So some examples of if they're like terms or not. We have a and a squared. They are not, because you cannot have an a and a squared. They have different exponents, so they're not like terms. We can't combine them. This one over here, 4x and negative 8x, would be considered like terms because they're both they both only have an x to the first power, so we can combine them. 4 take away 8 is negative 4, and we keep the x with it. So we had 4x's and negative 8x's, so combined we would have negative 4x's. This third example on the next line, 5xy and 3yx, although they're written differently, these are still like terms. Because of the commutative property of multiplication, we could rewrite this as 3xy. It's the same thing. And so we can combine these. If we added them together, that would give us 8xy. All right, the last example in light blue here, we have a squared b and ab squared. These are not like terms because the squared term is on different variables, and it would need to be on the same variable. All right, so let's just practice combining like terms here. So I'm going to look for things that have the same variable with the same exponent, and I'm going to either circle or underline or something like that to tell myself what I need to do. So I have 3x squared and 2x squared. Those can be combined. I have a y and a negative 4y, and then I have a constant, this 3, that is on its own. And so I'm going to combine my x squared terms. That would give me 5x squared. I had 3 and 2, so I added them together to get 5. I have 1y take away 4y, which would give me negative 3y, because 1 minus 4 is negative 3. And then I would just stick the constant on the end. All right, let's do some more practice here. I have a 3ab and a 5ab and a negative 6ab. These are all like terms. And then I have two constants, negative 2 and 7. My pen is doing something funny. So I have 3 plus 5 would give me 8, minus 6 would give me 2ab, and then negative 2 plus 7 would give me 5. All right, the third example of combining like terms. I have an x squared and a negative x squared. I have a negative 4x and a negative x. And then I just have this constant 9 that is on its own. There's no other constant. So if I look at x squared, take away x squared, these are opposites. They're going to cancel out. Negative 4x take away x would give me negative 5x, and then the constant 9 comes down. And that's it. All right, distributive property often leads to combining like terms. Not always, but sometimes. When we use the distributive property, we just multiply the outside by what's on the inside. So a times x would just be ax, and a times y would be ay. So I'm just multiplying the outside by what's on the inside. So if I'm going to distribute this 4, I would do 4 times x. That gives me 4x, and 4 times negative 3 would give me negative 12. And since it's negative 12, I write minus 12. There's nothing to combine. Those aren't like terms. All right. I've got x times 2x. If I multiply an x by another x, this creates x squared. And then x times negative 9 would be negative 9x. All right, let's do a harder example where we have some combining at the end. So I'm only distributing the 2x into the parentheses, not the thing that's on the outside. So 2x times 4 would give me 8x. And then 2x times negative x would give me negative 2x squared. Again, x times x gives me an x squared. I would drop down this minus 8x that's on the outside. Now I can combine like terms. I've got an 8x and a negative 8x, and those two cancel as like the problem before. They are opposites. 8 take away 8 is 0, and 0x is just 0. So these would go away, and I would just be left with negative 2x squared. Hope this clears up combining like terms and the distributive property.